Black holes are very fascinating objects in space and have many weird properties. But why do they seem to break the second law of thermodynamics? And how are we sure that they don't? The second law of thermodynamics states that entropy in a system is always conserved and increasing. But what is entropy? Entropy is simply energy's desire to disperse. If you have a chessboard, the pieces are all arranged in certain configurations. These configurations have high entropy. The pieces have many ways that they can be arranged on the board. If you only have the kings, however, there's not much you can do to mix them up, and therefore, this configuration has low entropy. When a black hole forms, it starts as a large, high entropy star. The heat and gas in the star are moving all around chaotically. When it dies, it condenses into a very dense spot, which is a black hole. The black hole now has all of the mass and energy and only one possible configuration. Using this reasoning, black holes have zero entropy because the total entropy has been removed from the fabric of the universe. This would directly break the second law, as it would destroy the entropy that it consumes. How can this happen? Well, it turns out that the entropy is not actually destroyed.
Imagine a rubber band ball. The rubber bands added increase the mass, and they are in one solid ball, but all of the other bands are still saved on the surface.
Almost all mass and energy in the universe is actually found in black holes. Just like the ball, the entropy stays on the surface of the black hole. This is very slowly released as thermal Hawking radiation until, after many, many years, all of the mass and energy is released back into the universe.
Take this ball, for example. The entropy of the matter, seen here as beads, are pulled into the black hole and stick to the surface. Then, after an incomprehensible amount of time, the individual particles are turned into pure energy.
This conservation of entropy is governed by the second law of thermodynamics. In 1974, Stephen Hawking found that entropy is proportional to the surface area of a black hole, finally proving that black holes are not guilty of breaking the second law of thermodynamics by maintaining the energy that they absorb. Black holes are spooky objects that seem to defy a lot of what we know, but even they can't defy the laws of science.